Good morning, good evening. Not sure what time you're watching at, but glad you're with me today. Hey, we've already talked about how algebraic expressions can be used to represent real-world situations. We've talked about that quite a bit this year. For example, 3x plus 20. I don't know, maybe you make $20 for a certain task, plus you receive a certain amount of money for the 3 hours that you're working, okay? That's something very basic. But before we talk any further about these types of things, we need to define some terminology. You know how your parents might say, "Hi there, how you doing, sir?" And you guys might say, "What up, dog?" Well, sometimes when people speak differently, sometimes there's confusion in what's meant by certain phrases. So just to clarify, get us all on the same page, let's start out here. Some of these things that we've already dealt with in the past and that we'll deal with in the future are called monomials. Other ones are called polynomials. A monomial has a very specific definition. It is either a real number, so a fraction, a positive number, a negative number, a decimal, any number that is considered to be real. It is a variable, so x, y, p, whatever you want to come up with, or it's a product of a real number and variables, as long as your variables have whole number exponents. So if that was a lot to process, let's take a look at a couple examples. We've got monomials right here. 3, it's a real number, so it's considered a monomial. M, it's a variable. 5 times x, it happens to be a product of a real number and a variable. 0.035 times a variable with a whole number exponent. Right there, it's a monomial. Last tricky one right here. W divided by 9. You might think, well, isn't that a quotient of a variable and a real number? And it does appear that way. But this thing can be rewritten as 1 over 9 times w. And 1 over 9 happens to be a real number, and w happens to be a variable. And since they are a product, since this is a product, technically that is considered to be a monomial. Now over to our non-monomials. You've got a variable and a real number. But since they're separated by a subtraction sign, they're not a product of each other. That's two different things right there. That is not a monomial. The square root of m, not a monomial. Unless m is a perfect square, so like the square root of 16, which would give us 4. Okay? Any number that's not a perfect square and is a square root is not considered to be a monomial. Y to the negative first. That is not a whole number exponent. Okay? 1 over y. It's the opposite issue of what you had over here. Not a monomial, also not a monomial. Now, more importantly, onto the polynomials. Okay, a polynomial is a single monomial, or it's a sum or difference of monomials. So what that means is that you can take any one of these monomials and you can combine them using an addition or subtraction sign, and together they're considered to be a polynomial, meaning many, okay? Like polygon, multiple sides. So here we go. Come down to this table and I'll give you a few examples. Monomials, we already talked about. Binomials. Bi meaning two, okay? We say that there are two terms in a binomial. So if you look at our first example, x minus 3, we say that x is one term and the 3 is another term. We say that 5 times x is one term, okay? It's one monomial, and the 1 is another one. Same thing's true over here. As you move down to a trinomial, same type of thing. We got one monomial plus another monomial plus another monomial. So as we move down, let's attempt our first question. Pretty simple though. State whether the polynomial is a monomial, binomial, or trinomial. Okay, the only thing you have to worry about is, can I combine this guy with this guy? I cannot. They are not like terms, since I have an x squared term here and I don't have one over here. So this is two separate monomials, which we call a binomial. Part B, pretty simple. It's just a number monomial. Lastly, this is the only tricky one. If you look at this, it looks like there's 4 terms. And there are, but before you classify it as to what type of polynomial it is, you need to see, can I combine anything? Are there any like terms here? And if you notice, there is an x here and an x here, so we should combine those. 1x plus another x is plus 2x, and you still have minus 3y. And now that we're done, we cannot combine anything else. You see there are 3 terms, and we call this guy a trinomial. So let's go ahead and flip our paper over. Try and keep this on the screen for you. And here you go. You know the word evaluate. So let's evaluate each polynomial. We've got a and b for x equals -2 and y equals 5. It's pretty simple. All you're going to do, plug these guys in. This shouldn't seem too complicated to you guys. 5 times 5 is 25 times -2, -50 is our answer. I'd like you to attempt part B on your own and bring that answer tomorrow. Now on to our application problem. The polynomial -16t squared plus 140t gives the height in feet reached by fireworks in t seconds. If the fireworks explode 4 seconds after launch, at what height do they explode? So this is where these quadratics from the other day get pretty cool. Okay, so this function actually tells us how high our fireworks are at a certain time period after we've shot them off. So if you plugged in 0 for t, meaning we have not shot the fireworks off yet, you'll see you obviously get 0 as your answer. So obviously they're still on the ground. They're at a height of 0. If you plug in 1, you'll get an answer. That's how high your fireworks would be 1 second after launch. So it seems pretty simple. How do we figure out how high they are 4 seconds after launch, or in this case, at what height they explode? Well, we got our function here, which models height. We want to know 4 seconds. We can plug it in for t. So let's do that. Since we're given the amount of time after launch that these things explode, it makes it pretty easy on us. All we have to do is plug in the time value and solve. So 4 squared is 16. -16 times +16. Thank goodness we know our perfect squares. It's -256 plus 560. And then when you simplify this guy, you're going to end up with 304. And I'm sorry, what are the units? That's right. We're talking about height. That's what the question asks us to find. So your fireworks are going to explode at a height of 304 feet. So, to sum up, I'm not going to do this for you, but tomorrow I hope you'll come in with number 1 answered. Number 2 might take you a minute to think about, but really, seriously, take a minute or two to consider it. Consider what we've talked about. And also, don't forget, I'd like you to come back up here and do part B if you have not already. And I'll look for that tomorrow. And we'll see you then.